Are you looking to strengthen your memory or to help a loved one who's having trouble remembering words or important events? Then don't miss our town hall, Memory and the Mind, What Science Tells Us About Brain Health. Leading experts break down the latest research on memory, cognitive aging, and brain resilience. Coming up, we explore what's normal, what's not, what we can do at any age to protect brain function and stay mentally sharp.
Thank you to the Eunice Joyce Gardner Charitable Foundation for its leadership support of the Health Channel.
Hello, welcome to our special town hall, Memory and the Mind, What Science Tells Us About Brain Health. I'm Pam Giganti. Thank you so much for joining us. The brain is the most complex organ in the body, but it's also likely the least understood. There's so much about the brain to know and to discover, and one part of brain activity that is both precious and mysterious is our memory. Our memories shape who we are. They hold our experiences, our relationships, and our sense of identity. But memory isn't perfect. We all know that. Forgetting things from time to time is normal, especially as we age. But if normal forgetfulness begins to disrupt everyday life, it may be time to see a healthcare provider. The good news is that there are things we can do now to protect our brains and to help preserve our memories. Today we're going to explore how memory works, what happens when it changes, and what we can all do to keep our brains healthy. And we have an outstanding panel to guide us today. Dr. Daphna Shohamy is the Kavali Professor of Brain Science and Director and CEO of Columbia University's Zuckerman Mind Brain Behavior Institute in New York. Dr. Paul Kenny is director of the Friedman Brain Institute at the Icahn School of Medicine at Mount Sinai Health System in New York City. And Dr. Vidhya Rangaraju is research group leader at the Max Planck Florida Institute for Neuroscience and NIH Director's New Innovator and Chan Zuckerberg Initiative's Early Career Investigator. Thank you all so much for being here. Appreciate it. We're going to have a great chat today, I know. All right, even though neuroscience has made enormous progress, the brain remains one of the most complex systems we know.
Take a look at this.
The brain is the most complex organ in the body, responsible for most of its functions and all of our thoughts. So, how does it work?
It's like a city. On any given day, you know the traffic will be about this thick on that road and the pedestrian traffic will be about this thick on that place. And you know that things are going to get produced and things are going to get shipped out and things are going to get shipped in. And it's all going to happen with nobody running the show, right? It's just everybody doing their thing. Well, the brain is like that. How does that happen? How does all of this work together to keep us running smoothly with nobody in charge?
All right, Dr. Shohamy, we have learned a great deal about the brain in recent decades, but how much do we actually understand about how it works?
It's a fascinating question and an actually really intriguing one when we ask how much do we know. And one way to think about that is to say we by far know more now than we ever did before. And it's a time of really rapid expansion of knowledge and an enormous amount of discovery. And one way to characterize it is to really recognize the complexity of the brain. What does it mean to understand the brain? The brain is made of so many different parts, right? There's sort of cells, and there's metabolism in the cells, and the cells that connect to one another, and there are structures. And everything we do, from breathing to falling in love to organizing a show like this one, uses the brain at all those different levels of complexity. One of the most interesting things I think about the time we're in now scientifically is that we're starting to understand how all those different levels connect. And part of the reason that that progress is something we're seeing lately is because we're starting to bring together different kinds of scientists, like you're doing here today. People who are studying the brain by looking at either the cells or the circuits or the behavior and bringing them together to really start to understand these sort of complex interactions of how a biological organ, in some sense, like our heart or our liver, gives rise to something like the human mind.
Yeah, and you talk about cells and circuits. Dr. Kenny, let's talk about neurons. What are they? We hear so much about neurons and synapses. What are they? What does that mean? And why are they so important?
Yeah, neurons are basically the functional unit of the brain. The human brain contains over 80 billion of these little cells. And again, you can think of them as essentially little electrical/chemical engines. Their job is to receive information, typically from other neurons, process that information, figure out how to store that information, and are involved in recalling that information. And ultimately, that's what a memory is. So they are what makes the brain work.
So Dr. Rangaraju, talk about the synapses and how those connections are so important in just our brain function and also creating memories, because we're talking so much today about memory. So talk about the synapses and the job that they perform.
Yes, Dr. Kenny mentioned that the brain is made up of 86 billions of neurons, and each neuron talks to 1,000 other neurons at these synapses. Synapses are where the neurons talk to each other. They are the junctions, and synapses are also the sites where memories form. And when you have a new experience, you learn a new language, you learn your new grandchild's name, or you go to a store for the first time, if that experience happens repeatedly, or if it has an emotional weight, the synapses get a signal that this memory needs to be stronger and stored, and therefore the synapses get stronger and larger. And so this strengthening of the synapses costs a lot of energy. Thousands of molecular machines are working together to make the synapses stronger and larger. And this synapse strengthening is where our research comes in. We have found that there are tiny biological power plants called mitochondria that are stationed right near these synapses, and then they get activated just when the synapses need fuel. And so then the mitochondria get activated and provide the energy to these synapses for them to store the energy, to use that energy to store the memories in their structures. To give you a sense of scale, the brain is about 3 pounds, but it uses 20% of the total human body's energy. So, and most of this energy is used at these synaptic junctions and for storing memories. So when you are thinking about memory, we are really thinking about energy. And so when the power fails, or the power supply, mitochondria fail, there is no memory.
Wow, fascinating. Great way to think about it is just like this little power station, the mitochondria, to power those synapses. All right, but neurons and synapses aren't the only parts of the brain involved in memory. There's another structure that plays a critical role. It is called the hippocampus. So, Dr. Shohamy, many people have heard of the hippocampus, but what exactly is it? What role does it play? Where is it in our brains, and why is it so important?
The hippocampus is a structure that's shaped a lot like a seahorse. And in fact, the word hippocampus comes from the Latin word for seahorse. And you each have 2 in your brain, 1 on each side, located behind the ear. We discovered the really important role of the hippocampus in memory through a very interesting case of a patient who's very famous in memory research, known as patient HM, who had very severe epilepsy. This was in the 1950s. And in order to treat him and save his life, a neurosurgeon went in and removed the part of the hippocampus that was causing those epileptic seizures. And inadvertently discovered after the fact that by taking out part of the hippocampus, he may have saved the patient's life, but he also rendered him unable to create new memories. He remembered who he was from before, but it was basically a sort of landmark discovery showcasing that the hippocampus is a structure in the brain without which we can't create new memories of moments in time, memories of moments like the one we're all experiencing now.
So that was my follow-up question. If it's damaged, what happens? But you just told us, no memories, right?
Right.
Yeah.
And I think and that was in the 1950s, what's been really exciting since then is actually the recognition that on one hand, there was something very selective that was damaged when you took out the hippocampus, so this loss of a particular kind of memory, which we refer to as episodic memory, but also the recognition that the hippocampus doesn't work alone to create these memories. And moreover, as we've discovered, since people without memory who lose the ability to create moments in time for the long term also lose something else, which is they lose the ability to think clearly and imaginatively about the future.
Wow, fascinating. Dr. Kenny, talk to us then about, if the hippocampus is so vulnerable, is there a way that we can protect it? What can we do to protect our hippocampus?
Yeah, evidence would suggest some of the best ways of protecting your hippocampus are, healthy habits, good sleep, regular exercise, really have a profound impact. Exercise in particular, you oxygenate the brain. The hippocampus responds very favorably to that. It releases various factors to help sustain healthy neuronal activity. There's even evidence with exercise you can produce new neurons in the hippocampus. They're sparse, but they appear to be functionally important. So exercise is really one of the best things we can do to maintain a healthy brain. And like I said, diet also plays a key role. Healthy food, not enriched in fats and sugars, all the things we know that we probably shouldn't eat, at least not too much of. A prolonged period of an unhealthy diet can be quite detrimental to memory, to hippocampal functioning.
Yeah, which shouldn't be too surprising to us, right? About the
Probably
exercise, healthy diet. We hear that about everything, whether it's cardiac health, et cetera. It's all connected.
It
right?
absolutely is,
Yeah.
and we can see the impact. You can actually see how these lifestyle choices impact physically the shape and functioning of the hippocampus, and then behaviorally, how well your memory works, how well you can use the hippocampus because it's functioning well.
Right. So, Dr. Kenny, we often think of memories in different forms: visual, auditory, even emotional. Are those types of memories encoded differently in the brain? And then just to follow up on that, what is the difference between short-term memory and long-term memory?
Yeah, the brain is essentially modular, so different pieces have different roles, but they all have to integrate together. So, as Vidhya had mentioned, different memories are generally stimulated. The brain decides to encode something because it's considered salient, it's considered important. But why it's important is likely reflecting the different types of information that arrive. For example, you could see something in the environment that is striking, potentially threatening, for example, so you have visual information that's encoded by the visual cortex. You could hear something like startling noise that will recruit the auditory cortex. There could be an emotional component. You could see something very pleasant or very aversive. So that will recruit areas like the amygdala that are involved in processing emotion. And ultimately, all this information has to be consolidated, integrated to understand what it is that you're trying to encode. So memories tend to live in different parts of the brain, but you need to bring all that information together. And typically, that's where the hippocampus plays an important role. It serves as essentially an integrating center so that you can collect, store, and then use the information afterwards.
Absolutely, okay. And Dr. Shohamy, the brain is constantly processing information, as we know. So how does it decide which memories to keep? And you and I were kind of talking about this whole scaffolding, right?
Right.
Yeah.
I think it's one of the most interesting questions out there, and I think most of us often feel frustrated. We don't get to choose what we remember. You might be experiencing a really wonderful moment, and you tell yourself, "There's no way I'll forget this," especially with children and family, these magical moments, and before you know it, it's gone, the memory. Part of the challenge of why it's so complicated for the brain to what we would call kind of prioritize some memories over the other has to do with what I mentioned earlier, which is that memory is not really as much for the past as we used to think it was. It is very much a process, a function that our brain uses also to plan and think about the future. So there's your challenge. How important will this moment that we're all sharing together be in our future is something that we can't ever know until later. And so one of the key tricks that the brain uses is that it's constantly updating our memories over time so that the jury isn't out right when the moment happens, but the brain has these molecular cellular tools to tell us in a week or 2 weeks to kind of go back to a memory that happened before and update it with information that comes later. So in a sense, memories in that sense are really alive and changing in a way that constantly orients to what's important to us down the road.
All right. it's just fascinating, right? I love the updating part. It makes me think about how you go to an experience and then you keep reliving it in your mind, like maybe the dinner you had out with friends and you keep reliving that conversation. That's kind of an example, right? And you keep kind of going back to maybe the conversation that you had.
Right, I think it's a great example, and it's something that's constantly happening. We don't have to do it effortfully. We don't have to decide to update our memories, but just automatically, naturally, our brains are connecting every moment to what happened before and anticipating what can happen later. It's sort of this connecting thread.
The connecting thread. Can you talk a little bit about emotions, especially stress, which are so powerful on our memories? How does stress in particular affect memory?
Yeah, so we were just hearing earlier about how sensitive neurons are in the hippocampus to changes in oxygenation and changes in metabolism. Neurons in the hippocampus, the cells of the hippocampus, are also very sensitive to stress hormones. So when we're experiencing a moment of stress, our body responds with the release of hormones, and those bind to the hippocampus and change its function. In the short term, it can be really beneficial. So there's a evolutionary advantage when you're stressed to be encoding that moment and recalling related moments. So it can be a good thing. Over the long term, exposure to stress, on the other hand, can be detrimental and damaging to the hippocampus itself. It's probably that relationship between stress and the hippocampus, for example, that connects to why often in trauma people have memories that are so vivid and irrepressible that they start interfering with daily life.
Yeah, indeed. Okay, Dr. Kenny, I want to talk to you about how do we, I think a lot of us think if I want to memorize a phone number, for example, which none of us do really anymore because it's all encoded, it's already in the phone, call mom. But if we wanted to memorize something, what's the best way to do that? Do we just keep repeating it over and over again? Or what's the best, maybe for students, et cetera, what's the best way to memorize something or information?
Yeah, as the father of a student in college, I'd like to have a great answer for that. But I think, repetition is very important. So if the brain decides to encode information and wants to store it, typically it's because it is important. And so to a large extent, memories live between cells, they live between neurons, and we've heard about synapses. So synapses essentially encode the information, but synapses are incredibly dynamic and they flex very quickly. You can see that in real time. When information's being encoded, they can get bigger, physically bigger very quickly, and in the efficacy, the degree of communication between neurons, which is essentially what a synapse is, can be strengthened very, very quickly. And as you recall this information, you can see that flexing occur, and if you want a memory to be encoded long term, recalling that memory, strengthening those synapses, and eventually those strengthened synapses become permanently strengthened. In other words, the memory is there for the long term. That is really how memories become ingrained in the brain. So repetition is important, but that typically works not if you repeat something like my students want to do for an exam rapidly approaching. You're trying to repeat something kind of rapidly, but within a short period of time. It can be somewhat efficacious. The best way is to recall repeatedly over extended periods of time. That way you're constantly engaging these circuits, you're stimulating those synapses, you're flexing those brain muscles, and then that memory or those memories are more likely to be there for the long haul.
So you really shouldn't cram for the exam, is what I'm hearing. That's a pretty short-term memory if you're lucky, right? Dr. Rangaraju, let's talk a little bit about sleep. How important is sleep? We've talked about body systems and eating and exercise, but sleep is so ignored, but so important, right?
When the brain is in the awake state during the day, it's in the recording mode. And when we go to sleep, it switches from recording mode to a filing mode. That is when it is sifting through the experiences of the day and it decides which ones to keep and which ones to be stored for the long term. So when sleep is interrupted or disrupted, this filing mode gets affected and therefore memories don't get stored. Recent research in fruit flies actually show how mitochondria trigger sleep. They find that the mitochondria are releasing these chemical byproducts as a product of generating energy throughout the day. And as these byproducts accumulate and they build up, they switch the brain state from awake state to sleep state. And so if the mitochondria do not function normally, they do not switch the brain state to a sleep state, and that therefore damages mitochondria further, and which further impairs sleep, and it becomes a vicious cycle. So sleep is very very important. It's important to consolidate memories. It's important to clear the waste. And it's also important to recharge the power plants, mitochondria, so that your brain cells can stay healthy.
Dr. Shohamy, pick up on that. What else can we do to, because I know your work is specific really in memory and decision making. Talk about things we can do to really improve that.
You know, one thing that I think we haven't mentioned yet in this conversation is the importance of novelty. The brain is constantly making predictions about what's going to happen next. And when its predictions are wrong, it's a signal that you need to create a memory. You need to learn something new. And that is something that we know is really powerful for driving the creation of memories is newness, novelty, new things. So taking a different route to work than you usually do will enhance the likelihood that you encounter something new and encode new memories. Traveling, meeting new people, and I think this constant the ability to expose ourselves to new information and surprise our brains is something that can be very healthy for keeping our memory functioning well.
That's such a good point, because we get into our habits, right? We just keep doing the same thing over and over, but we're not helping our brains by doing that.
In some sense, because habits are important too, but habits are the brain's efficient mechanism for not having to think about it. Like releasing us to think about other things.
Right.
We want to balance that with newness and excitement and mistakes and opportunities for also creating new modes of information.
Good, that's nice to hear. All right, by our 50s, many of us begin to notice subtle changes in memory. Most of these are completely normal, but they can still be concerning, especially for people who have seen dementia affect somebody who they love, like the caregiver in this video. Take a look.
Living Minute, a look at the latest medical innovations changing our lives.
Kenya's mother has Alzheimer's disease. She often worries that the forgetfulness she sees in herself could be an indication she's more likely to get the disease.
I mean, at my age, I forget where the car keys are sometimes. I forget things. And now that I'm looking at it, I'm like, wow, am I going to have the same diagnosis as her? And so it's very scary, because when you have your mom that gets it, you know, a lot of times people get things from their mothers. My aunt now, who is my mom's sister, is now having forgetfulness.
While family history may increase your risk of Alzheimer's, it doesn't mean everyone related to a person with the disease will develop it. Speaking with a health professional can help answer questions or concerns you might have.
So many of the cognitive changes that we experience with age are expected. These can include things like slower processing speed, difficulty finding words, misplacing items, and increased distractibility. Dr. Kenny, let's start with processing speed. What does that mean exactly, and when should somebody get concerned?
Yeah, essentially processing speed is the ability of the brain to acquire new information, process it, encode it, and then utilize that same information. Those processes, processing speed, generally speaking, and all the bits of the brain and processes in the brain that are involved will of course change over time. Processing speed can, for certain things at least, slow down as we age, and that's perfectly normal, it's perfectly fine. I think it only becomes a concern when a slowing of processing speed begins to impact your day-to-day life in a way that's detrimental. And if that begins to occur, that then seems like it's moving outside the norms that you would expect with regular aging. And that might be when it might be time to seek advice in terms of whether changes in processing speed may reflect something a little bit deeper and more concerning.
Especially if we have somebody in our family who's going through something like we just saw in that video, we're like keenly aware, and we forget a name and we start to kind of freak out, right? But we need to, we might be okay.
Yes.
We might be normal.
And it's a dynamic process. Stress can impact it, day-to-day events can impact processing speed, but there's underlying trends that may be more persistent that are much more important to watch.
Gotcha. So are there strategies that can help people process information more efficiently? A follow-up, word finding difficulties can be frustrating. So Dr. Kenny, what's normal and when that might signal that something's more serious? I mean, even all of us were hanging out in the green room talking, and some of us would say, oh gosh, what is so-and-so's name? And I know you know her. And why does that happen?
Word finding problems, perfectly normal, perfectly natural. Again, it speaks to the degree to which this occurs and how impactful it is in your day-to-day life. and the degree of change. In other words, if you feel that this is progressing, it's becoming more impactful and it's more noticeable, either to you directly or to people around you, that may suggest that something a bit more concerning and deeper occurring. But losing a word happens to all of us. I know it happens to me every single day, and that's perfectly normal.
I think it's just because we're all really smart. There's a lot of information in there, right? So Dr. Shohamy, if somebody is struggling to find words, could there be other explanations besides dementia?
Yeah, I think it's really important and probably worth emphasizing. You know, a very big discovery in recent decade or two is that healthy aging is distinct in the brain from dementia. It's not that we're all going to end up with dementia. It's a disease, and we now understand a lot more about it than we used to. Difficulty in retrieving words of the kind we're all describing, that's a clear sign of healthy aging. Show me someone who hasn't suffered from that, probably from their 40s and on. The term we use for that is goal-directed retrieval. It's that situation that happens when you're looking for a particular word or a name and you just can't find it, and it comes back later, but you can't find it when you want to find it. That's sort of the profile of the natural loss. And so I think it's very important for people to recognize it. That in and of itself is not a sign of anything but healthy aging. And the reason that happens is because healthy aging causes changes in our frontal cortex. And our frontal cortex just doesn't work to communicate as effectively anymore with our hippocampus. So it sort of struggles to get the word when we want it sometimes.
Yeah.
But it doesn't feel good when it happens.
It doesn't.
But not a cause for concern in of itself.
The author, Arthur Brooks, I don't know if you've, and he wrote a lot of great books about aging, and one of them he says is there's a little man who goes up in your brain and he's looking for the name. You've got so many books in there because we're so smart. He said, you'll find it. It's just he's going through the books. So that's always my joke with my husband is just give me a minute, the little man's on the ladder in my brain. I'll get it to you. So, all right, Dr. Shohamy, so many experts now say that our brains remain capable of adapting and growing throughout life. So talk about what are some of the most effective ways that people can maintain or even improve their memory as they age? Because it's really never too late, right?
It's never too late, and I think it's important to remember that it's not all bad news. So we know there are a lot of things that change for the better with old age. I used to think this was a particular story that had to do with my grandmother, who decided to write a memoir when she was in her 80s. I now know that that's actually probably reflective of changes in the brain where people get better at looking back and identifying trends and identifying patterns. It's something that we often equate with wisdom, which we know scientifically measurably improves with age. So I think it's important to recognize this trade-off between forgetting the name of the person you met yesterday morning, but also gaining the ability to recognize patterns, gaining wisdom, and gaining, I think, in some sense we see in the lab this sort of deeper connection with age between what you remember and how much it means to you.
I love the part about wisdom, right? Just the longer we're here on the planet, the wiser we get, right? Just lived experience, All right, Dr. Kenny, one of the strongest recommendations we hear from scientists is physical exercise. We've kind of talked about that. How does something as simple as just regular movement help the brain and memory? Because we've talked about exercise, but we also discussed in the green room as well how just going for a walk is an easy thing to incorporate, that movement is also really important for brain activity. When we say exercise, we don't have to go out there and go for a run or do anything strenuous, correct?
Absolutely. It's hard to overstate the positive impact of exercise and brain function on whole body function. It really is quite remarkable. And so it may seem like almost like a throwaway line. If you exercise, it's beneficial, whereas people are looking for the real answer to maintain a healthy brain, healthy aging. Exercise really is a key part of that. It gets the blood flowing. It really helps clear the brain out, wash out what shouldn't be there, and help it to function in a way that as optimally as it possibly can. So again, it is very hard to overstate just how beneficial exercise is for the brain, for cardiovascular health, and cardiovascular health is intimately entwined with brain function. And so it really is important to get your heart rate up on a regular basis.
Yeah, I like how you talked about it moving things out. And Dr. Rangaraju. Let's talk a little bit about mental stimulation, because it's another key factor as well. We understand that exercising stimulates the mitochondria, which you've already talked about. Please explain the role mitochondria plays and how exercise can help. You have told us that it's sort of the powerhouse of the neurons, et cetera, but talk about exercise and mitochondria and how that all plays a role and how important that is.
The brain runs on 20 watts of power. That's like the power used by a dim light bulb, right? But the brain can do way more than a dim light bulb. It can outperform a supercomputer. How does it manage that? It is because it's highly efficient. It is able to produce energy just when it's needed, where it's needed, and how much is needed. Neurons, especially the brain cells, have a very complex morphology. They can stretch long distances. It's like the highway that runs from Florida to Massachusetts along the length of the East Coast. And you can think of the mitochondria as local fuel depots along this highway. And the mitochondria are locally providing the energy to these neurons and these synapses as and when they are needed. And our research shows, as I mentioned, that mitochondria position near these synapses, and then they are activated. And what we have found is that this activation signal. So when the synapse receives information and it knows that this memory needs to be stored, in that same process, calcium floods into the synapse, and that calcium then enters the mitochondria that is close to the synapse. And that calcium then activates all the enzymes inside the mitochondria and says, hey, now we need to produce more energy. And that energy in turn goes to the synapses and fuels that memory formation. So now you can think that the neuronal activity is a great signal that communicates to the synapse, to the mitochondria, to say, hey, we need to store this memory and fuel this memory. So now this is where exercise comes in, right? So exercise is a great way to increase this. The physical activity is a great way to increase neuronal activity. So while you're exercising, you're really activating the mitochondria to produce energy and to provide fuel to this memory to be stored in the synapses. And the other thing that exercise does is that it delivers oxygen to the brain, and oxygen is a key ingredient for the mitochondria to produce energy. So when you are exercising, you're basically activating and re-oiling this energy-producing machinery so that you can keep the cells alive, healthy for longer.
I love that picture, the oiling of it, right? Keeping it going. So we also know that music and the arts play an increasingly important role in helping people of all ages, but music therapy is being specifically studied when it comes to Alzheimer's and patients with other neurodegenerative diseases. Experts aren't crystal clear on how it works, however. Take a look.
Living Minute, a look at the latest medical innovations changing our lives.
Music is part of a growing interdisciplinary field called neuroarts, which explores how the arts can change the brain, body, and behavior. Neuroarts researchers are working to better understand how music specifically can help with memory in dementia and Alzheimer's patients.
I think one of the most important imperatives for the neuroarts field, in fact, is to actually do the rigorous hard science to understand how it is that hearing familiar music, so you hear it in your ears, it's interpreted somewhere in your brain as familiar, and that somehow then interacts with parts of the brain where memories are stored. To unlock them, we don't yet have that information.
All right, Dr. Kenny, so what do we know about how music helps to evoke memories and how that can really help patients with Alzheimer's and dementia?
Yeah, we still understand relatively little about that, but I guess one way of thinking about it is, if I go back to what I said a little earlier about the brain being modular in structure, different pieces have different functions. Certain parts of the brain are involved in encoding salient sounds, salient auditory information, and music is most certainly salient. And so how that information is stored in the brain is still unclear. But if certain types of memory may be hard to access as dementias evolve, other information, it appears, you can still access, and you can tap into those kind of deep-seated memories. And music may fit into that type of category where the information is still conserved, it's still stored, and you can trigger those memories by being exposed to familiar music. It's another way of accessing that deep interconnected network.
Yeah, it opens the door, right?
Yes.
Especially when you hear a familiar song that takes you back to another period in your life or to high school or something. It's very powerful.
Yes.
Yeah. All right, Dr. Shohamy, music and the arts seem to evoke strong feelings, as we've just talked about, and often good feelings in all of us. So let's take a look at this video about that.
What happens inside of our heads when we look at art? How does our brain react to a portrait of a face? And is that different from how it reacts to something more abstract? Scientists are just beginning to explore these questions, and they're doing so using a concept called psychological distance, which tells us that the farther away something is, the more likely we are to think about it in abstract terms. Let's say you're planning a picnic with friends. If the picnic is going to happen later today, you're more likely to think about concrete logistical details like where exactly to go and what food to pack. But if the picnic is going to happen in a month from now, you'll probably think about it in a more abstract way, like how nice it's going to be outside with your friends. To see if this link between distance and abstraction applies to art, scientists ask people to look at different paintings and make choices, like this one. Imagine you're an art dealer. Would you display this figurative painting in a nearby gallery or in a gallery far away? What about this more abstract painting? Where would you display it? And let's think about time. Would you show this painting in an exhibition opening tomorrow or one next year? In these experiments, people tended to choose displaying the abstract paintings farther away, in time and in space, and how much they liked the paintings had little effect on their choice. This is the first evidence that different kinds of art can affect our choices, and that they do so by putting us in different mindsets.
That's so interesting. It seems like so subjective too, right, Dr. Shohamy, depending upon what kind of art you like, abstract or... So in your research, have you looked at that with art and how people are attracted to art and how that changes the brain and their memories?
Yeah, I think, to me this is a really exciting nascent field. Not nascent because we as humanity haven't considered the role of art in our subjective human experiences, which we have and continue to, but being able to link these big questions about the human experience to the brain, that's where new research is really happening now. We have the technology now to ask questions about the human brain and its patterns of activity in ways we just didn't have back in the day. So it's opening up new questions of the kind we just saw. And what's so interesting, I think, here is there's a concept in art history called the beholder's share. And the idea is simply that from the art perspective, when we look at a piece of art, it's not just what's in the art that we enjoy or don't enjoy or are moved by, it's also what we bring, our own associations, our own memory, our own baggage. And this was really the first experiment that I know of that we did that asked, how does that happen in the brain? And when you think of it from the perspective of a memory researcher, which is how I came into this interest in art, it's not surprising because we know that our memories shape every interpretation of every moment. And so we're beginning to understand how that plays out in something as kind of uniquely human as enjoying and being moved by art.
Yeah, and just go to a gallery and you'll see it's a unique experience for each person, right? Dr. Kenny, what do memories teach us about ourselves and about one another?
I think everything. Memories ultimately are who we are. I mean, we live in the moment, but how we place ourselves in that moment is ultimately based upon our life experience, who we've interacted with, what we've experienced in the past. So it could be argued that ultimately who we are is a collection of all the memories that we stored up until that point in our lives. Again, very philosophical, but memories really do make us the person that we are.
Indeed. Dr. Rangaraju, what are your thoughts?
I mean, especially when it comes to different senses that brings the memory together. We talk about the R's, which is talking to all the different senses at the same time. At the molecular level, the way we think about it is the synaptic connections, for every sense, synaptic connections are forming at different parts of the brain. And more the synaptic connections, the more efficiently you will retrieve it later. And now, if you, it's almost like nailing a picture with 1 nail versus 4 nails. Especially smell, for instance, is strong because it is directly linked to the amygdala and the hippocampus, and therefore just a little bit of, sometimes a familiar scent can really vividly take you back many years ago and to fond memories.
Yeah, it's so fascinating, isn't it?
Is there a certain food or a variety of foods that are really good for the brain? We hear all of it, and I'm not talking about whatever the supplement is on television.
Yeah,
I mean food.
Yes, food is a great way of putting it. We look a lot at this in my lab. How does food impact brain functioning? And what we found is that you know all of this, but I'll say it anyhow. The more processed the food is, the worse it is for the more detrimental it is to your brain. And by processed, what I mean by that is you take ingredients that typically don't go together in nature. You take refined sugar, refined fats, and you put them together. Those things typically do not happen in nature. That can have a very detrimental effect in your brain. How it functions, the longevity and kind of plasticity of those cells. It's really problematic. So I think the more natural a food is, the more the body understands what it is, processes it accordingly, and your brain benefits from that. It's when you begin to put things together that really shouldn't go together, and we all know what those foods are. Things that are high in fat, high in sugar, high in calories. In other words, all the things we like to eat. And it is important that you kind of understand that these are not innocuous things. It's not just your waistline that will be impacted. It very much can be your brain, including the hippocampus. So they can be very problematic, these types of foods.
If I were to add to that, the brain receives all its nutrients from the blood. And that comes, so the blood is the one that carries glucose, oxygen, all the nutrients to the brain. And if the blood vessels are clogged by high cholesterol, high blood pressure, or poorly controlled sugar, then the brain does not receive the nutrients it needs. So it's there. So what is good for the heart is good for the brain. That's a simple equation to follow. Of course, the other things that we know is leafy greens and berries that have antioxidants which are known to neutralize toxic chemicals, especially the ones created by mitochondria. And there are also omega-3 fatty acids which have been used as power foods that are important because they get integrated into the membrane of the neurons and mitochondria, so it's important for their function. But in addition to these additional food factors, the one thing that current research is exploring is to think about not only certain food sources, but also alternative fuel sources. For instance, in the Alzheimer's, the brain loses its ability to process glucose. So in those cases, the current research is showing that alternatively using fats as a fuel source could then be used as a healthy lifestyle choice.
Yeah, I have a quick question for you. We talked about sleep and how important sleep is. Are naps helpful?
Yes, naps work like sleep. In fact, there has been research that shows that if you are trying to remember something or memorize something, once you practice or memorize it repeatedly, and if you take a short nap, you would remember it better. As I mentioned, just like sleep, nap is also that filing. You're turning on the filing system in the brain, which means it uses that time when everything shuts down to reconsolidate the memory and transfer it to long-term memory storage.
Maybe I can jump on that as well.
Yes, please.
Up until a few years ago, we didn't think the brain had a lymphatic system, but over the past 10 years, we've realized that it very much does. And one of the functions of this so-called glymphatic system is basically to power wash your brain while you're asleep. You can accumulate detritus, byproducts of simple metabolism in the brain. Throughout the day, they accumulate. When you're asleep, your blood vessels basically open up. and the brain undergoes this power wash, and it collects all the gunk that shouldn't be in there. And there's evidence to suggest that if you can facilitate the process when you're asleep, it lowers the amyloid burden, for example, in people with Alzheimer's disease. So there's considerable interest in terms of what sleeping-induced power washing of the brain, what it may do and how beneficial it could potentially be.
Clearly, nutrition is a huge factor. Fats like avocado, walnuts, and so forth, that's kind of what I'm hearing. And I do a lot of work in trying to keep my brain, I think most of us all do. Exercise is also important. I think a lot of us know that. But the one thing you've talked about, novelty, and since I put a career in education, I discovered the older we get, the less interested we are in learning something, because learning requires novelty. It requires our brain to build those connections, to use the neurons. And the truth is, sometimes it's hard. Sometimes it's easy for us to just give the remote or a new cell phone to our grandkid, tell me how it works, rather than do it ourselves. But there's a value in doing it for ourselves, isn't there? And what is it about learning that we shy away from when we know, in fact, that it's good for our brains?
It's a great question. I think I'd modify something you said a little bit, which is that we shy away with age from certain domains and not others. So what some of our research suggests is that when people are older, if you give them a memory test on random words, and do they remember them the next day, they do worse. If you give them a memory test where they get to choose what kinds of information or what kind of words they're interested in, and then test their memory, then the memory looks almost exactly like young college students. So if you allow the choice of a domain that people are interested in, you really see a different cognitive profile emerge. So I'd say rather than fight that and try to figure out how the phone works, let your grandchildren figure that one out, but keep learning about the things that you do find interesting. And by doing that, you're going to engage your brain in a much more meaningful way. I really like what that research suggests, not just in terms of sort of a hopeful and simple rule of thumb to use, but also I think it really emphasizes the fact that as we get older and know more, we can be a little pickier about what we want to know, and that it's good to go with that.
If I could add to that, one thing that I want to highlight is that what is happening in the brain when you're learning something new. The brain is amazing in the sense that it can be both stable and flexible at the same time. So by being stable, you're able to remember a memory 40 years ago, say a wedding day. And by being flexible, you're able to learn a new language even at the age of 70. So this flexibility is called brain plasticity or neuroplasticity. And this plasticity is driven when you learn something new, when you challenge yourself or you do exercise. And mitochondria also play a role because plasticity is basically the synapses getting larger and stronger, and mitochondria powering that plasticity. So life choices, as we talked about, like adequate sleep, routine exercise, balanced diet, all of them are important to keep the mitochondria healthy, and then therefore help the mitochondria, help the plasticity going so that we can make the most advantage.
I have a question, and I'm interested in what the brain is doing and how I can get it to stop doing it. 2 weeks ago, very quickly, I went to a concert, heard about 20 songs with words. That night, I listened to more music. One of those songs continuously repeats. I don't know, I can't stop it. I wake up every morning. That is still going there. I want to know why, and I want to know how to stop it.
That's a great question. Who wants to tackle that one?
Well, I'll give it a try, maybe. I'd say in terms of how to stop it, I mean, what, for some reason, and maybe arbitrary, maybe there's something meaningful to you, your brain created a very strong memory for that, and now you're also maybe a little bit obsessing about it and wanting it to stop, which is sort of like not thinking about, the elephant. And but I would listen to other music. I think is a really good tip, and I might intermix that song in with other pieces of music rather than avoid it altogether. So you want to create new traces. You want to take advantage of the natural updating that the brain does by connecting it to other kind of musical sounds.
And maybe I could say, maybe not necessarily wanting to stop it. If I knew how to start it, I could see a new career as a music producer. So if you get the answer, please let me know.
Well, this has been wonderful. Thank you all for being here, our live audience. This was lovely, and thank you all. It's been such a pleasure. We've all learned so much, and we know your time is valuable, so thank you for being here and sharing all of your wealth of information. We hope that tonight's conversation has given you not only information, but hope, because when it comes to brain health, one message is clear. It's never too early and never too late to invest in your brain. I'm Pam Giganti. Thank you so very much for joining us, and we'll see you next time.
Thank you to the Eunice Joyce Gardner Charitable Foundation for its leadership support of the Health Channel.
The 50-year history of the National Institute on Drug Abuse, NIDA, is marked by scientific breakthroughs that have changed our understanding of addiction, a chronic, often debilitating disorder that affects tens of millions of people worldwide.
When I look back at the 50 years of NIDA's research, I'm stunned about how many advances in science we have made and how researchers have actually affected positively the life of so many people. When NIDA was founded, our scientific field was in its infancy. We had just discovered a key opioid receptor, but we didn't know what were the endogenous neurotransmitters, nor did we know what dopamine was doing, nor what was its role in addiction. We had a couple of treatments that are medications for substance use, but we have no evidence-based behavioral or prevention interventions.
On May 14, 1974, Congress established NIDA as a federal focal point for biomedical research on substance use and substance use disorders. NIDA is now the largest funder of research on drug use and addiction in the world. NIDA's support for basic neuroscience research has been instrumental in advancing our understanding of the mechanisms by which drugs affect the brain. Researchers now use scientific advancements unimaginable 5 decades ago. Developed with the support of NIDA and other NIH neuroscience institutes, these techniques help researchers to probe the brain circuits involved in addiction with unprecedented precision. NIDA's investment in basic science and drug development led to the U.S. Food and Drug Administration approval of new medications to treat opioid use disorder. Its research also contributed to FDA approval of nasal naloxone, which reverses opioid overdoses and saves hundreds of thousands of lives each year. NIDA is funding studies of dozens of novel compounds for treating substance use disorders, including stimulant and other drug use disorders that currently lack medications. Epidemiologic research, supported by NIDA, has helped researchers understand patterns of drug use over time. This work is informing prevention science and leading to effective interventions for reducing drug use and the progression to addiction. Nicotine addiction remains the deadliest substance use disorder in the U.S. To better understand tobacco use and related health outcomes and inform tobacco product regulation, NIDA and the FDA launched the PATH study. The largest long-term study of brain and cognitive development in children, the ABCD study, was funded by NIDA and other NIH institutes to increase our understanding of adolescent development and the factors that can impact a young person's life trajectory. It is delivering important results on how drug use and other experiences affect young people. And it set the stage for the HBCD study, which will follow pregnant people and their infants from pregnancy through early childhood. Over the last 3 decades, research on the intersection of substance use and HIV has transformed care for both conditions and demonstrated the effectiveness of harm reduction approaches like syringe service programs. Amid today's overdose epidemic, NIDA remains committed to giving people the tools to survive. This includes developing new treatments for opioid use disorder and overdose, and prioritizing implementation science to ensure that effective interventions get to the people who need them. NIDA's investment in small business innovation has led to a range of devices and applications for preventing, diagnosing, and treating addiction and its health effects. These include the first FDA-approved virtual reality therapeutic for chronic lower back pain, and a commercial application of wastewater technology to identify the presence of drugs in communities and inform local public health interventions. Additional examples of research NIDA is supporting to speed solutions to the opioid overdose crisis include studies of mobile health clinics and telehealth, which hold promise for people who face challenges accessing treatment. Testing new treatment models for the many people in jails and prisons who have opioid use disorder. Exploring how best to deliver harm reduction interventions like naloxone and fentanyl test strips. And increasing support for research to reduce health disparities and build research capacity in underserved communities.
NIDA's 50th anniversary allows us to acknowledge the scientific advances in addiction science. But it's also a time to recognize that and renew our commitment to the mission of using science so that we can actually bring solutions and tools to those that need them.